But yeah, so we haven't focused too much on like improving your code and thinking about optimizations. That's again something that's very important for software development, but the nature of a boot camp, like we just want to teach you the fundamentals and get you guys coding and learning new technologies. So haven't always been able to take time to talk about making improvements to your code. So that's kind of the main topic of today's lecture. All right, so the overview of what this presentation is going to cover. Just going to give you some personal advice on taking technical interviews because this is going to be something you guys are going to be doing if you guys do want to become software engineers. I'm just going to have an overview of, just my general recommendations. Again, some of those are, recommendations you're going to hear if you Google like how to prepare for technical interviews. So it's going to be pretty basic information, probably a lot of it you've heard before. I just want to go over kind of how I approach technical interviews. Then we're going to have a practice technical coding challenge, and I think we're probably just going to do that together on screen so we can kind of get that down together. And then finally, we're going to be going into talking about how we can actually improve our code. So this is something, again, that is really important to kind of grasp if you want to become like a software developer. Improvements are very important to the game. All right, so first we're going to talk about my general advice for technical interviews. So not passing a chance for alliteration, I have Encore's advice for acing assessments. So there's two main buckets here. One is how to prepare ahead of time, and second is obviously how to succeed during the time of the interview. So preparing ahead of time, what do I recommend? So usually you'll have a point of contact who set up your interview, whether it be like a HR personnel or maybe, I don't know who else it might be. But yeah, usually you should have a point of contact who set up your interview and can answer any of your questions. So take advantage of this connection. Like, ask all the questions you can just to better know what to expect for the interview. So typical questions that I like to focus on are, one, ask what type of interview it's going to be. I have had interviews where I thought it was going to be technical and it was not a technical interview. It was more behavioral. So being prepared can go a long way. So, you want to ask, is it a behavioral interview? Is it going to be just about your background? Is it going to be a technical interview? Is it going to be some hybrid? Always good to kind of ask and know what interview you're walking into. Again, definitely don't want to be surprised when you get to the interview and, they start asking you questions like, oh, wait, I didn't know you're going to ask me that. So yeah, definitely try to ask and figure out what type of interview you're going to actually have. Next, always good to ask about programming languages. You don't want to assume like you could just code in whatever language you want. A lot of this might come back from the job description. So they should list like, oh yeah, we want to, we're a Python shop, or we use JavaScript, or we use, C++, whatever it may be. But always ask. You never want to assume that, okay, I can just code this in JavaScript, so I'm just going to, brush up on my JavaScript. Yeah, so usually you can assume if they have it listed in their job description, but always good to just ask. Like they might give you options. They might be like, yeah, you can code in Python or JavaScript. So that way you have some flexibility and can pick which one you're most comfortable with. Another one, great question to ask is, what topics are they going to focus on? So, in the world of programming or computer science, there's so many topics out there that could be covered. You want to kind of narrow it down. So if they're able to say, yeah, we're going to focus on data modeling questions. So then you can kind of know, okay, I'm going to dedicate my time ahead of time to focusing on data modeling instead of, doing everything that we've, gone over. And there's so much more. Like we could talk about classes, we could talk about, CSS or styling. We could talk about like APIs. We could talk about, so many topics out there. It's kind of impossible to kind of just study them all effectively. So if you can narrow it down, if they're willing to tell you, yeah, we're going to ask you back-end questions or front-end questions or whatever, area they're going to focus on, if they could kind of tell you ahead of time, it's just going to help you focus your time more efficiently. All right. And then, yeah, it's always fair to ask, like, if they have any suggestions for preparations. Like they might say, yeah, go do questions on, SQL queries, for example. Yeah, they might not give you that much of an answer there, but it doesn't hurt asking, right? So they might be able to point you to resources like, yeah, we have this link here, just kind of study the questions on here. Great. That just, again, makes it more focused on what you can focus on ahead of time. So yeah, again, definitely the main takeaway here is take advantage of the contact you have, whoever set up the interview or reach out to. whether it be a recruiter or an HR person. Just kind of like, yeah, ask them anything when you have an interview set up. Make sure you know the full details. The key is you don't want to be surprised by anything when you walk in. You should be confident and prepared effectively when you walk into the interview door. And then, as always, Google is your friend. So this isn't anything revolutionary. Just Google common interview questions for the job or the company that you're interviewing with. There can be, I know Glassdoor is a great resource. A lot of times, some people post questions that they encountered from the interview, so that could kind of, give you a ballpark of what they're going to ask. It might be the same question, might be related, who knows? But yeah, just kind of Google what typical questions you might see for your specific job role. Again, kind of narrow it down. Like, don't just search for common software questions because that's pretty broad. Make sure you know what the role is, and then Google for that specific role and see if you can find typical questions that are asked, and then kind of practice that way. Also, if you're not aware of other resources that are great, HackerRank, CoderByte, and LeetCode. These are popular coding sites. So companies use them. I've definitely had a bunch of interviews on HackerRank, maybe a couple on CoderByte. I'm not sure if LeetCode offers like actual interview questions, as in like for corporations, but they have a ton of practice questions, and that's probably my favorite site out of these three. Basically, it's just a repository of challenges that you can take. They're bucketed into easy, medium, or hard. So I think it's a great way to both practice your skills and actually like learn new languages. So you can code up your solutions in probably like 6 or 7 different languages. So that's actually kind of my first exposure to Python. I kind of just, tried a few problems in Python, picked up the syntax, kind of looked stuff up as I needed. But LeetCode would be my top rec from these three. Any questions on HackerRank, CoderByte, LeetCode? Have you guys used them before? Have you guys seen them before? I'll assume that's a yes. All right, so moving on. Last thing, this might be obvious, but some people kind of overdo it. Relax. That's very basic advice, but I think it's really important. Don't put too much pressure on yourself. You're not gonna do well if you're just like up until like, let's say 3 a.m. the night before, trying to cram in all the information you can, and then your interview is like 9 a.m. the next morning. A good night's sleep goes a long way. So, practice, definitely prep, take some practice questions, but don't overdo it. Your mind needs time to kind of like relax and recover and be fresh for an interview. So yeah, don't put too much pressure ahead of time. Just, prep a little bit, but don't kill yourself trying to, study like 5 minutes before the interview starts. Okay, yeah, so those are my three general tips. Ask questions if you can, get the most information you can about your interview, use Google, practice, and then relax ahead of time. And then we get to the actual interview day. So interview days can be, really grueling. There's a lot of pressure. I'm not saying like I'm totally cool and calm under interview sessions, because they're timed, they're asking you questions, they're grilling you. Not always fun, but make the most of it. So again, you're gonna have different types of interviews. You're gonna have behavioral question interviews, questions about your background and experience. So definitely prepare for those, but my focus is gonna be on technical interviews. So I have a list of steps, just how I kind of approach a technical interview during the interview session. And again, a lot of this might be basic, but hopefully you guys kind of understand my approach. And if you guys kind of agree with it, can kind of adopt it yourself. If you have other, like a different mindset, totally up to you. We all kind of think differently. So step one kind of ties back to relaxing, is take a deep breath. Again, I've gone through many interviews, and it can be a lot where they ask you a question and like the clock starts ticking, right? Usually these are timed interviews. So it's really easy and common to just to panic, like, oh God, like how do I attack this? How do I solve this? Like your mind starts racing, like let's solve this problem, like let's get going. But taking a deep breath goes a long way, honestly. Kind of just like relax yourself. Again, you're usually not gonna perform well if your mind is like worrying about other stuff, like, oh no, do I know this? Oh no, like, do I have enough time? Like, sure, those are concerns, but don't try not to let that get the best of you. So take a deep breath, kind of just like, try to relax yourself and approach this problem in a cool, calm mindset. Then we move on to step two. So this is where kind of digesting what they've asked you and, trying to formulate your thoughts and create a game plan. So this is where we talk about like pseudocoding. So you get like mentally pseudocode or, start pseudocoding in front of your interviewers. But always pays off to, invest time up front to formulate your solutions rather than jumping in right away. So the comparison I'd go with is like, let's say you want to cook something. Usually you don't just jump into the kitchen and just throw a bunch of ingredients like into a pot or like, just start like cutting up a bunch of ingredients and not knowing where you're going. Usually you want to have like, an understanding of what your end goal is. So I might be like, okay, I want to make pasta. So maybe I need to start boiling water. And then maybe you need to get out the pasta sauce or whatever, steps are required. So again, you don't want to just rush into it without having a good understanding of what you need in terms of like ingredients, or I guess for technical interviews, like just like, what data structures you're gonna be working with, what maybe like functions you need to create. But yeah, always good to kind of think about that, because the other side of it is you might start coding, like go down a path and then realize, oh wait, this is not actually gonna work. Or wait, I got to use a different data structure. So I'm gonna change my code that I've written already. So it's gonna be wasted time potentially if you go down a path and then realize it's not the actual path you want to go down once you get deeper into the problem. So yeah, just take a couple minutes. It's totally fair to ask your interviewer, like, hey, can I take a minute to kind of just formulate my thoughts? Like they're not gonna say no, right? They're gonna say, okay, yeah, take your time, ask questions, which is the third step. Always ask questions, even if you feel like you 100% know what they're asking. Still ask questions. This is twofold. One, it shows that you understand what they're asking of you. And if not, like let's say you, for whatever reason, assume something differently or just read the question wrong. If you ask questions to your interviewers, they can know whether you understand what they're asking. So if I ask like, oh, do I really need to, create this class? And they'll be like, yeah, it's, pretty vital for this challenge. You got to create a specific class. But yeah, so again, just to clarify and get that communication going back and forth, ask questions. Again, even if you think you 100% know what they're asking, try to come up with at least a couple questions just so they know that you're on the same page as them in terms of what the solution should be. All right, and then step 4, very important. Some of you guys might have a lot of practice with this already. Others of you maybe haven't had a technical interview. I know we've done some technical interview practice, but always talk. Talk during your coding. It's easy to kind of just get in that zone and just like try to code up a solution without really vocalizing what you're trying to do or what you're thinking. And this kind of ties back to our previous point of communicating so that your interviews can guide you if you're on the wrong track, or they just get an insight into your mind and kind of can better analyze you as a candidate. Like if you mention like, oh, I'm going to, this is an n-squared solution, but maybe I could do better. Like they're like, oh, this guy's actually, or this candidate's actually thinking about complexity, or they're thinking about the right approach, and that's a check on our checklist of items that we're looking for. So yeah, always try to talk as much as you can. Again, this might be a little let's say a little uncomfortable because we're not used to like talking as we code, right? Usually I assume when we're coding, or when I'm coding at least, like I'm just focused on the task. I'm not verbalizing out loud because I'm coding on my own and there's no one around. But during an interview, it is very important to talk so that your interviews know kind of how your mind works, because that's what they're trying to gauge you on. All right, so those are my 4 first steps. Again, nothing revolutionary, but kind of the gist of it is, don't rush into it. Relax yourself, ask questions up front so that like what you're supposed to do, as opposed to assuming. Especially going back to questions, like it's always good to ask about assumptions you're going to take, because they might be valid assumptions, or your interviewers might be like, no, you can't actually assume that the inputs are going to be valid. That's a typical, I guess, gray area where sometimes they might give you a challenge and they want you to like error check or like, make sure that the inputs are valid. Other times they're going to say, yeah, you could assume the inputs are valid. You don't have to worry about, validating correct values and stuff like that. So always good to ask those types of questions so that any assumptions you're going to take, you should confirm that they're valid. And then, yeah, talk during your interview. So we went over that. All right, 5 more steps here. Again, I know it's a lot, but always good to kind of have that flow here. So number 5, probably the most, maybe the most important, is get to a working solution. So there are times, again, with technical interviews, they are grading you on more than just getting a working solution. Again, they want to see that you're mindful of like testing or, of efficiency and maybe other criteria. But a working solution is probably the top top thing that you can deliver. So even if you know, like in the back of your mind, like, yeah, this isn't going to be a good solution, but it's going to be a solution, still go with it, right? Delivering something that works has some value. So don't get too bogged down in like, okay, well, let me spend like 15 minutes of my interview trying to just figure out the best solution and then start coding after that. Because usually these technical interviews are pretty squeezed for time. So like there might be some buffer area, but in terms of time, but usually they're not going to give you like 2 hours if the problem takes a half an hour. Like they'll give you probably an hour if the technical challenge is expected to take most candidates like 45 minutes. So you do have some wiggle room, but definitely just try to go with your initial thoughts. So, when you took the couple minutes up front, just if you came up with a plan, just go with it. Don't spend too much time trying to figure out a better way or, just trying to nitpick at your initial solution. So yeah, get to a working solution should be your primary goal. And we've kind of talked about this before, but just to reiterate that handing in something that works is better than nothing at all, right? That's hopefully we all agree with that. So that's number 5. And then number 6, test your code if you can, especially with simple inputs, just to verify that that your solution works. And 2, this goes back to just like showing your interviewers that you're mindful about testing. So if you write up a solution and just hand it in, like, yeah, if this works, I'm good. Well, great, it might work, like it might be 100% correct solution, but if you never bother to test it, that kind of shows some lack of initiative and I guess like polish in terms of your software mindset. Because testing, again, we've talked about testing a lot, is very important. You might have missed the edge case. Again, it might be 100% solution, but always good to kind of just test it with simple inputs, like in front of your interviewers, just like, all right, let me put in like a very minimal input, work it, like go line by line, go like, all right, this line is gonna compute the square of this number. I don't know what this algorithm's doing, but yeah, just go line by line, kind of talk about what the inputs would actually do as it's traversing through your code. And that's just an easy way to verify your solution, and 2, show that you're mindful of testing. Again, this is if you have time for it. So again, number 5 is going to take you the bulk of amount of time. But if you finish, try to test. At least show that you make an effort to test. All right, and then we go to 7, adding improvements. So again, this is only if you have time for it. But once you get a working solution, iterate upon it. So this is, again, going back to the notion of don't just be content with a working solution, or just if you finish a project and be like, okay, I'm done, this project's complete. Usually there are improvements that can be made, whether it be like efficiency improvements or design improvements. There's a whole list of ways you can improve your code. So always, again, be mindful of improvements. Even if you don't have time for it, talk about it with your interviewers. Be like, all right, maybe you have 5 minutes left in an interview, you can't like restructure your algorithm. But if you came up with a better idea as you're coding, you'd be like, oh yeah, actually, if I had, if I had more time, I'd go back and change this algorithm to do this, X, Y, or Z. Again, be specific. And again, this will give your interviewers a sense of, okay, well, maybe they didn't have the most optimal solution that they handed in, but they're, again, cognizant about making improvements and can actually articulate what can be changed about their base solution. All right, so test and add improvements if you have time. Number 8, this one is hopefully something you're prepared for, but big O questions are very common. So analyzing your solution, both from like complexity and just like other aspects, is a typical question. So they're going to ask like, okay, you have the solution. Can you talk about why you made this design decision? So you should be ready to back up your decision. Like, all right, I went with this class because it made sense, because we're creating objects, and classes offer the ability to create multiple objects pretty easily. So yeah, just be able to analyze your solution and talk about why you chose to do what you did in your solution. Again, my big hint here is big O questions are very common. I'd be surprised if you go through interviews and don't get asked big O complexity questions. So this is just a high level being able to analyze how efficient or inefficient your solution may be. So definitely go back to our big O lecture that we had, probably week 4, week 3, I don't remember when it was, in case you're still kind of fuzzy on big O. Again, it's not too, I guess, complicated of a concept to kind of understand. I mean, it's a little more, takes a little practice, kind of, have an eye for and understand identifying complexities, but just understand the idea of analyzing complexities within your code. And number 9 is probably my most personal question, because I don't know if everyone does it. Maybe everyone does do it. I don't know. But I'm always focus on asking about the correct solution at the end of the interview. So obviously you can't ask during the interview, like while you're taking the challenge, but once I hand in a solution, whether it be in person or like online, I'm the kind of person that wants to solve it no matter what. Like if I run out of time, which has happened on a technical question, like I still want to solve it on my own, just to have that knowledge and just to have that, I guess, that satisfaction that I was able to solve it, even if it doesn't count for anything. So I often, again, going back to our, either you have your interviewer's contact information or HR contact who could give, channel communication to your interviewer, but ask about the correct solution. One, because it'll show you the answer and kind of hopefully help you learn like what you did wrong if you didn't get to like the best solution or weren't able to complete it. But also, again, I'm not going to say that's going to probably change anything from the interviewer's perspective, but at least they see that you actually care about knowing the answer, right? Like if you completely bomb an interview, that might happen to some of you. Like I'm not gonna say everyone's gonna ace all their interviews. Like if you completely bomb an interview, yeah, it's not gonna feel great. It might happen to some of you guys. It's happened to me where like I just don't complete a problem and I'm like, well, that kind of sucks. Ran out of time or whatever, just couldn't solve it. But I always want to know the correct answer. So kind of asking about it after the fact can kind of put like a positive note in your interviewer's mind, like, okay, well, they didn't do all that great, but at least like they want to know and want to improve. So again, that's likely not going to get you a job, but you never know. So asking about the correct or the more improved solution is always a good thing to practice and go about for your interviews after you complete it with them. All right, so a bunch of steps there. Kind of want to pause in case anyone has any questions about any of these items. Hopefully they all made sense. Hopefully you guys, again, nothing revolutionary there, but again, some of us I know some of you guys have never gone through a technical interview, so hopefully some of these steps kind of make sense or something you didn't think of before. But yeah, any questions? All right, hopefully I'm not putting you guys to sleep. All right, so those were my tips for acing coding challenges or technical interviews. All right, so let's actually get to a coding challenge. Let's do one together. So hopefully you guys got your coding windows out and can do this on your own screens, but we're gonna do it together also, so don't worry. This is our task. This is a coding challenge that I'm gonna offer up to you guys. So given, the problem reads, given a positive integer value of n, return the largest numeric palindrome that can be produced, again, if one exists, that can be produced by multiplying two n-digit numbers. Otherwise, return 0 if no such palindrome exists. So kind of take a moment, digest that, and please ask questions if it's not clear on what we're trying to get to.
Could you give an example of an input-output?
Absolutely, great question to ask. In interviews, great to kind of ask for a simple example. Oops, sorry. Okay, so let's go to our coding window, and yeah, I'll give an example here. So bring up a new window. Sorry, I have some coding windows open here. Let's call this coding challenge. So yeah, so I'm gonna do this in JavaScript. You guys can pick your favorite language. All right, so I have this coding challenge, and I did have something written up here. Sorry, I had some dry runs earlier. Okay, so this is JavaScript, so not pound signs. But yeah, so I think it was Christian who asked for an example, and that's totally a fair question to ask during an interview. So I have an example here. So again, reading the question again, given a positive integer value of n. So let's say n equals 2. In this example, basically we're going to be multiplying every two-digit number out there and formulating a product. And then we want to find the largest palindrome that we could produce by multiplying those numbers. So in the case of n equals 2, we're going to multiply two-digit numbers. We're going to multiply a single two-digit number by another single two-digit number. So in this case, we're going to go to 11 times 11, 23 times 37. Again, the whole box of two-digit numbers. So in this case, for n equals 2, the correct answer for this problem would be 9009. So that's a palindrome because it reads the same forwards and backwards. So again, 9009 is the same backwards and forwards. And that is produced by multiplying 91 times 99. So your algorithm should output 9009. And the indices that actually produce those values are 91 and 99, which are both two-digit numbers. All right, another assumption that you can make is that you can assume that n will be kind of like a valid number between n equals, so you can assume it's going to be positive and less than 8. So this is a problem that blows up pretty quickly, as you guys might see. But yeah, so n will be a legit number. You don't have to worry about error checking or integer overflow or anything like that. All right, again, maybe take another few seconds to kind of digest that, maybe formulate your thoughts of how you might attack this problem, and then we're going to do this together on screen. And I might ask for a volunteer to assist me. Again, I will code along with you. I'm not going to strand you on an island. There's my Zoom window that always pops up on the wrong screen. All right, hopefully you guys kind of have a good formulation of how you might attack this problem. Any volunteers who want to code along with me, or I might just pick someone up from the screen. All right, Caitlin Wilson, you're actually first on my screen. Would you be willing to code along with me?
Sure.
All right, sounds a bit hesitant, but don't worry, we're gonna work through this together. So Caitlin, do you have any initial questions about this coding challenge?
None that come to mind yet.
Okay, so as our first approach, could we like come up with a good pseudocode game plan? So I'm gonna kind of ask you what steps you might take to kind of just outline what you're gonna do. Again, not implementation details, just pseudocode in terms of what steps we need to accomplish.
So you need to, 1, take in the number. 2, you have to create a list of all the numbers that fit that parameter, like how many digits you're looking for. And then you would have to multiply each number in that list by another number in that list to find out if it creates a palindrome. So
we'll multiply all numbers in our list. And then we're going to say step 4 will be determine if we have a palindrome from each multiplication. All right, yep, that sounds like something we definitely need to do.
What happens if there's more than one palindrome? Does it stop at the first one? Or should it find all?
Yeah, it's a good question. So going back to our question, so we want to find the largest numerical.
Okay.
There might be multiple, which is a good thing to keep in mind, because yeah, you definitely don't want to say, we found a palindrome, that's our answer, because there might be a larger one. So yeah.
So you probably want to store that. If you find the palindrome, store it for consideration.
Store all palindromes. Okay.
And then find the largest palindrome. If there is one, if there isn't, return 0.
Gotcha. Yep, that sounds like a great game plan. So find the largest from our results and return largest or return 0 if none. All right, yeah, I think that's a good approach. Again, we're breaking it down into smaller bite-sized chunks. We don't want to just say solve the problem because that's not descriptive, nor is that going to help us with our game plan. All right, Caitlin, yeah, I think that sounds like a great idea or a great game plan here. So, all right, so I think we have our pseudocode down. Does anyone have any additional steps that might need to be inserted here or any other thoughts?
You could, I mean, I was thinking you probably work backwards from the largest number.
Okay, so I guess, yeah, this may be an algorithmic approach. So like, so Michael O, if you can elaborate on that.
So if like, for the example, for instance, for n equals 2, it looks like if you started at 99 instead of starting at 1, you wouldn't really have to store the value or the ones that are palindromes. You just find the first one.
Okay. Yeah, that's a good thought. But so what would be your first multiplication?
You'd probably have to, yeah, exactly. So you'd have to come up with a way to get that starting value, the like largest value that you would start at. So you'd have to figure out, you have your n equals 2, and you know that before reaching 3 digits in that number, you'd have to stop at 99, for instance. So really it would just be like n, or 9 n times would be your starting value, I suppose.
9.
You could do it 10 to the power of n minus 1.
Yeah,
There you go,
sorry.
yeah.
Just to go over this. So we're going to start at 99 times 99. What's our next check going to be? If 99 times 99 is not a palindrome, what's our next, again, just walking through this algorithm that you have in mind, what would our next check be?
So you're going on and decrement one of those values by 1.
Okay, so we do 98 times 98. That makes sense. And then what's our next, after that, what would be our next one?
Well, I mean, you'd want to check to see if it's a palindrome.
Absolutely, yeah.
Between those.
Yep. Yeah, so we check 99 times 99. If that's not true, then we go down. What's our next iteration? Just kind of get an idea here.
I mean, it's just you repeat that process until you, so, I mean, are you asking how do you check if it's a palindrome or?
Oh, no. Just, I just want to know what our iteration is going to be. So we check 99 times 98. What would our next check be in terms of what values do we check next? Like after 99 times 98, what would the next multiplication we do be?
In the brute force approach, you would just continue decrementing that 98 to 97.
Okay, so yeah, so we have this, let's say like this. So if we did this, my question to you would be, just going off what you said earlier. So this is our approach. So we're gonna just go downward, and eventually we're gonna get, once we get down to like 10 down here, we're gonna go to like 98 times 98 and then go downward. So be 98 times 97 and so forth. So again, then we start decrementing the first one and do that again for the second value. Yeah, so that makes sense. But Mike, or question to anyone, is our first palindrome we find in this manner going to be necessarily the largest?
No.
It won't be necessarily the largest.
Right.
It will happen to be in this particular instance, but
well,
because 99 times 91, but it won't necessarily be.
Yep, you got it. So like if you look at 99 times 97, that's going to produce some value that I don't know. So let's just say it's, whatever. It's not 6,000. That's going to produce that. However, I do know that 98 times 98 is going to be slightly larger than 99 times 97 because that's a square. So that's just kind of how it works. So this is probably going to be like, again, these aren't legit values, but this value is going to be larger than this value. So hypothetically, if this were a palindrome, let's say this was like 6006, we found a palindrome, but that isn't guaranteed to be our largest because 98 times 98 might be this. Again, I know it's not true, but I do know that 98 times 98 is going to be larger than 99 times 97. So there might be a larger palindrome still out there if it's, even though it's not in our first pass where we're using all 99s. But I like the way you're thinking. So yeah, this algorithm can work, but there might be some additional processing we need to do because the first one we find isn't guaranteed to be our largest value or largest palindrome.
Okay. Yeah.
But no, I like the way you're thinking. You're on the right track there. But I'm just going to go with the solution the pseudocode that Caitlin and I came up with, and then we're just going to try to code this out. But there can be improvements. So I like that you're kind of thinking of other ways to approach this. So Caitlin, if I could get you back on the mic, can you kind of help me code this out? So I'm going to create a function. We're in JavaScript, so largest palindrome is what I'm going to call it. Reading our requirements, we take an input of n. So that's going to be your input here. Mistype palindrome. All right, so Caitlin, we're taking in a value of n. How can we create a list of all n-digit numbers? Do you have any idea there?
So I guess you'd have to loop through numbers, starting with
Yeah, let's kind of think about this. So if we have n equals 2, what are our bounds? As in, what are our values, like minimum value and largest values?
minimum value is 10, and the largest value is 99.
Yep. All right. So for n equals 2, we get 10 and 99. And then if we went to like n equals 3, the min would be 100, and the max would be, 9999.
So you always start with 1 and end with 9, however many times. So I guess you could start at the highest, like Michael was saying, we're storing all the values and just multiply 9 by the number of digits.
Okay. Yeah, that seems like a good idea. So if we start with n equals 2, well, how do we get the max number of 99 from n equals 2? I think Jeremy was maybe saying it earlier. Jeremy, do you want to offer your?
Multiplying it by the nth power, or whatever, 10 minus, or yeah, what Jeremy said.
Yep.
minus 1.
Yep.
So 10 to the nth power minus 1.
You got it. Yep. So in this case, we're gonna do 10 to the nth power. So in the case of n equals 2, we're gonna do 10 squared, which is gonna be 100, and then subtract 1 from it because we want to start at 99 because 100 is not a valid input for our specific problem because we only want n-digit numbers, so only 2-digit numbers when n equals 2. So yeah, we'll start at 99, and then what will our terminating case be, or what will our continuing case be? I guess.
It's larger than.
So n equals 2, we want a value of 10.
So
sorry, did someone else?
10.
10? Yeah, but how do we produce 10 here? Because like, if we went to n equals 3.
I see.
Yeah. But yeah.
10 to the power of the quantity n minus 1.
Yeah, that sounds good. Yeah, so we're going to do 10 raised to n minus 1. So in case of n equals 2, we'll do 10 raised to the first power, which is going to be 10. And so we test it with n equals 3. We'll do 10 to the squared, or 10 to the second power, so that's going to be 100. So yep, I think that should produce our upper and lower bounds. So good math lesson there. All right, and then we're going to decrement because we're going from our highest values to lowest values. So it's going to be I minus minus. All right, cool. So we have that. All right, Caitlin, so this should produce a list of all of our 2-digit numbers or n-digit numbers. What do we want to do next?
I want to store those values.
All right, so we're going to store that into a list or an array, I guess, in JavaScript. So let's create an array. Let's say let values non-descriptive field array, and then values will push each of these into there. All right, so we're going to create a list with our valid range, and then that's going to be our values array. All right, cool. We have that. What's next?
Now we have to compare those or multiply those values to each other.
All right, so how would we go about doing that algorithmically?
I mean, the easiest thought would be through a loop or a loop within a loop.
Okay, so let's create
a more efficient way to do it.
So let I equal values dot. How do we do this? So we do I equals 0, I less than values dot length, and we'll increment here. Okay, so we're going through our values, and then did you mention something about another loop?
Yeah, so the easiest approach would probably just to do a nested loop.
Okay, that makes sense. Well, again, our goal here is to get to a working solution. So anything that produces a correct result will be something good to deliver from a technical interview. Again, there might be other ways to go about this, other algorithms, other changes we can make. But right now, our first goal is to get the correct solution. So, all right, that makes sense to me. We're going to go through our values and then go through our values again because we know we got to multiply 2 numbers together. All right, so we're going to assume get a product here. This product will be I times j. Or sorry, values I times j. Any questions from anyone? Hopefully you guys are following along here. Let me scroll a bit so we're not at the bottom of the screen. All right, so we're gonna multiply our values from our loops, get our product. Okay, what's next in our game plan? So we did create a list, we're doing all the multiplications. Determine if we have a palindrome. So that's something we're gonna have to figure out. There's no, as far as I know, there's no magic function in JavaScript that says, is palindrome yes or no. So I think that's something we're gonna have to implement. Caitlin, do you have an idea how we could determine if a number, if our product is a palindrome or not?
I'm trying to think back to when we did the palindrome and split it into, it's like each individual digit and then flip it.
Yep.
And then compare the two.
Yep, sounds good. So I'm actually going to create a function for this. So again, hopefully you guys are still mindful about making your code a little more modular. So I'm going to create a function called isPalindrome because this is some separate logic. And this is going to take in some value. So let's call that number. And then the goal here is to determine if this number is a palindrome. So I think Caitlin was saying, and I agreed, we want to take this, maybe break it apart, and then flip it and see if it's the same. So let's do, sorry, give me a second here. All right, apologies there. Need to mute my notifications. Okay, so let's see. Let's do let number array equals number split. I'm not sure if this works. We'll try it. So split.
You have to turn it into a string first.
Yeah, that's kind of what I was wondering about. So let's do number string equals, is it just number 2 string? Someone help me out here, please.
I think
You just wrap it in.
Or would I do str and just wrap it like that? Actually, don't remember.
I don't remember the job.
Oh my, yeah, I forgot this JavaScript.
Google's for, so convert number to string. So I think we have 2 string method. All right, that should do it for us. Yep, 2 string should be good enough. There might be other ways to do it. All right, so 2 string. All right, so we're going to convert our numeric value to a string, and then we're going to split that string into an array. That's be our number array. So this should be number string. I think split's correct here. Correct me if I'm wrong. So we get a number array. How can we reverse it?
There's a built-in. Is there a built-in?
I think you're right. So I think it's array dot reverse.
Yeah.
Okay, so
And compare the two.
all right, and so now when you say compared it to, how can we compare them? So we do return number array equal number. Will that achieve it for us?
I don't know if it'll compare the actual index of each number.
Right. Yeah. So again, going back to I think it was like week 1 or 2. Arrays are non-primitive types, so you can't actually just do a direct comparison because it's actually gonna check if both arrays are the same array, not if the values are the same.
So you'd have to loop through.
Yep. So in that case, we do a simple for loop. So do let I equals 0, I less than number array. So we know the size of these arrays are going to be the same, so we don't need to bounds check both of them. We're just reversing one. All right, so we want to check if index I is equal to, sorry about that, the reverse index. And so if this is true, what do you want to do?
Return true. Or return, yeah, return true.
So return true right here.
Yeah.
Okay, can anyone see an issue with returning true right here?
It'll kick us
It'll
out
always
after the first one matches.
Yep. Yeah. So this is only going to check if our first, I guess first and last number because we reversed one of them. But yeah, so we'll only check one of them. So we might need to modify this a little bit. Any thoughts?
Just continue.
Can you just join the reverse array And then compare the joined reverse array to number string because they'll both be strings.
Yep, that works too. Yeah, so again, as we've probably said 100 times, there are multiple ways to achieve the same solution. So yeah, I think going through this totally works. Like we could check if this doesn't equal, we probably return false, and then return true if it gets out of this loop. But I think the other session, which is cleaner code, would be number array reverse dot join, and basically make that a string again. And then we compare that to our number string. So that I believe this will work also. So basically what we did was taking a number, convert it to string, convert it to an array so that we could call reverse on that array, and then simply join that reverse array and compare it back to our string. So now if our initial string that we converted to is equal to the new string that gets created by join, if that's true, then we know it's a palindrome. If these don't match, then this will return false. You guys all agree with that? All right, cool. I agree also. So, okay, that's our step number 4 from our pseudocode game plan. We determine if we have a palindrome. So we could, sorry, we have this else palindrome, so we can actually use it now. So I do something like if is palindrome product, we want to do something with it. So what do we do want to do if this is actually a palindrome?
Add it to another array.
Okay, so we're going to have, let's say, palindrome array. Array, get my let, then we're going to push it into here. So palindrome dot push, and we'll push the product in there. Okay, so that makes sense. We get a palindrome, we store it in our, sorry, not is palindrome array. Push that. Okay, that makes sense. So we're going to collect all the palindromes we find from this entire space. And I always mistype palindrome. I'm not sure why. All right, so we have palindrome array. All right, so let's say we get all the palindromes. Caitlin, what's the next thing we want to do from our game plan? So we did number 5. Yep.
So we have to find the largest palindrome in our array, if any.
Yep, that sounds good. I'm just going to copy over these comments. We have some commenting going on. Always get to comment again. Just bonus points when you're doing a technical interview. If you do have time to just add in a few comments, like obviously that's going to be a positive for you. So you're both helped your interviewers understand your code, and obviously they were like, oh, this guy comments or this candidate comments, so might put you above someone else that doesn't comment. Always those extra points can count. All right, so store all of our palindromes. And last thing is find our largest. So how would we find our largest? Sorry, I forgot if you said that or not.
I didn't say that yet. So I don't know if there's a way. I mean, you can sort an array, right? So
yeah, I think we could sort an array. So I think that's what's it? Palindrome array dot sort. Is it that simple? Let's actually try this out. So again, always good to kind of test as we're going. So let's assume we sort it. Let's print that out to our console and see what we should get. So console log palindrome array. Let's do this with, I guess n equals 2 should be fine. Should be too large of a space. And then we want to return something from a palindrome. So I'm just going to return 0 for now. Let's see what this produces, and then we'll modify that. So bring up my terminal over here. We have JavaScript, so that's node coding challenge.js. That didn't print out anything. Oh, because we didn't actually call it. Yeah. Always need to call it a function. So let's pass in n equals 2. So pretty simple case. And then I guess this console will print it out. So we don't need a double printout. Okay, cool. So it looks like we found a bunch of palindromes. Again, I guess 127 more. I guess it's not going to print it out for us. But all right, we called sort, and I'm not sure if sort actually sorted.
no, it's sorted by the first number as if it was a string.
Yeah, it might have. Yeah, I think it converts it to a string and then sorts it alphabetically rather than numerically. So sort.
Dan said something about max. I'm not sure how that would work.
Instead of doing sort, you could use the reduce function.
Okay, can you walk me through that? So I have palindrome.reduce. So yeah, if you guys aren't familiar with this array function, it's one of those handy dandy functions on top of, like, so we have map, we have filter, reduce is another common one. So how would I use reduce? Anyone know?
In parentheses within the reduce, it's A comma B.
Okay.
And then fat arrow. And then I believe it's A greater than B will give you the maximum value.
We'll do return A greater than B. All right, so we're gonna basically reduce is gonna return you one value, as opposed to map and filter, they return you an array, a new array. Reduce will basically return you one value, so let's give this a try. So I have max, let's print out max down here. And yeah, always good to test. Okay, so I got a false. That's not what I expected. So it's going to return a Boolean. Yeah, let's take a look at reduce. I might not know it too well. So reduce array function JavaScript. Google. Again, the downside is during a technical interview, if you're on like in person, you're not going to have the option to Google. But these days we have a lot of remote coding. So okay, so we have an array of 1, 2, 3, 4. We pass in an accumulator, which is the first value, and a current value. And then the accumulator will keep track of all the values, and the current value is what we want to investigate. So basically, in this case, instead of doing A greater than B, I think A is our accumulator. So let's say current max is that value, and this is new candidates. All right, so basically, I think if we could do something like if new candidate is greater than current max, then return new candidate. So I think if we do this, and I might be wrong, so when we return a value, that's what the new accumulator is going to be for the next iteration. And then if that's not true, we return current max. I'm not sure what this is initialized to, so we might want to initialize that to something. Say if not current max, let's return 0. All right, again, I'm not sure if this is going to produce what we want, but let's give it a try. So current max should be keeping track of the largest value we found. The return from a reduce function will update the accumulator, I believe.
I forgot you have brackets. Okay.
Okay, let's give that a run. I think we're close to a working solution here. Okay, there we go. We got a 9009, and I think from my example, if you guys trust me, that is the correct answer for n equals 2. So it looks like we got the correct value for n equals 2. Obviously, we shouldn't just settle for one case. Like we should try n equals 3, n equals 1. Again, that's like more of an edge case because one-digit numbers aren't too exciting, but always good to try that. So anyone want to tell me what the answer should be for n equals 1?
Would it just be
0.
There won't be a palindrome.
I got two different answers. So I got
9.
yeah, I got one person said there won't be an answer, another person said 9. So in this case, I would agree with the person that says 9 because technically 9 backwards and forwards is the same. Like it's a one-digit number, so it's again not too exciting. But any one-digit number is technically a palindrome because it reads the same backwards and forwards. So yeah, I would agree that 9 because 9 times 1 will produce 9. So we have two one-digit numbers, and we take the largest one of that. So yeah, I think 9 should be the answer. Yep, we get 9 output. N equals 3, that's not trivial. Like I can't tell you off the top of my head what the answer to that is, but something we want to test to make sure we do get a palindrome output. Might take a little more effort to determine if it's the largest, but I think I trust our algorithm. Just looking at it, that whatever this spits out should be the largest palindrome. So if we could try n equals 3, it's going to take a little more time, but let's give that a run. All right, there we go. This does look like a palindrome. Again, might take a little more effort to validate that's the largest one, but I think looking at our algorithm, I'm pretty confident this is the largest palindrome. All right, so this seems to be working. So again, we tested it. So again, that's one of the steps that I mentioned for doing well in a technical interview. Code up your solution, but also test it. So we've tested it. Seems like it works, so that's cool. All right, cool. Caitlin, thank you so much for stepping up and volunteer. I guess you didn't volunteer, but for yeah, helping me code this solution up. Any questions on this solution?
Ankur, would you mind running through the reduce function again and kind of explain what it's doing?
Absolutely. So reduce basically is going to iterate through all the values in your given array. And then you're going to pass it actually 2 values. So the first value is called the accumulator. So that is something that is keeping track of the past call to reduce, or the past iteration of reduce. And then the new candidate is actually the item it's investigating. So if I just name this item, make it a little more clear maybe. So item here is just the item in the array that we're currently investigating. So let me change this to item. And then whatever you return from your reduce function, or from this anonymous function here, that is the value of current or in this case current max for the next iteration. So if I returned, let's go back to our documentation because I think they're doing something a little differently. So in this example, they are returning accumulator and adding the current value to it. So the job of this reducer is to, of this reduce action is to basically sum up all the values. So the way they're doing it is calling reduce with this function. And so the accumulator is going to be, again, what you're aggregating. And then in this case, there's adding each value to the accumulator and returning it. So there's an implicit return here. So basically, the next time, so we walked through this, the first item will be 1. It's going to take 0, which I guess is the default value, and then add 1 to it. So then the next time around, when we get back to item 2, the values of accumulator is going to be 1, and the current value will be 2. And then we're going to return 1 plus 2, which is going to be 3. So the next time around, the accumulator is going to equal 3, and then we're going to add 3 to that. So basically, this just keeps like some memory of the previous value that was returned.
Okay.
And then
That makes sense. Thank you.
ultimately we'll return 1 value. So again, this is not going to return an array. It's going to return the final value of accumulator once it gets through this entire array. Is there a question? No questions?
No question, but I did come up with a one less loop solution.
All right, I will say that's great, and keep that in mind. We're going to come back to this. Great that you guys are thinking about improvements here. So let me clear this, not that. Okay, let's actually take a quick break. So we're at 9:52. Let's take an 8-minute break, and then we'll continue on the lecture here. So see you guys in a bit. All right, so our previous coding challenge that we solved together was given a positive integer value of n, return a largest numeric palindrome. So I think we successfully had a working solution that we created. So good job, everyone. All right, so let's go on with our lecture here. Who can tell me one of Nike's most iconic slogans?
Just do it.
You got it. Just do it. All right, so that's a, again, very, very iconic slogan. Everyone pretty much knows it around the world probably. But I have a slogan for you guys as software developers. So your software developer slogan, hopefully you guys are willing to accept it, is actually just do it better. So we've talked about not selling just for something that works, but also trying to improve it and make it better. So hopefully you guys all will adopt this mindset. Again, I can't force you to, but I highly recommend it if you guys want to be successful software engineers. Do it, just not selling just for something that works, but always striving to make it better and improve upon what you have. All right, so just do it better should be our slogan as software developers. So we come back to this slide. So you're not mistaken. You have seen this slide at least twice before. I always go back to this slide because I truly believe in it. And it's actually that simple in terms of goals of a software developer. It's really just twofold. One is solve a problem, and then 2 is solve it well. So you should always get something that's correct and that delivers the actual correct results, but you should always try to make it better. So again, we've talked about this before. We talked about structurally before, functionally. We kind of touched upon algorithmically. We did go into for big O analysis, which was a past lecture. We talked about how we could identify inefficient code, but we never really talked about how we could actually make it better. So that's actually the focus of this part of the lecture. So just to recap, again, some of this might be repeated information, but structurally, there's a number of ways you could make your code better. So one is just organizing your code better in terms of using files and functions. System architecture is the idea of just having the correct model for whatever your product is, whether, is it going to be a client server model, peer-to-peer network, just kind of understanding your needs and designing a proper architecture. So that's usually for larger projects, always pays dividends to invest time upfront and determine what your structure is going to look like, rather than again diving in just like trying to figure it out, and then it's going to be harder probably to get to adjust your architecture if you didn't think about it ahead of time. Future proofing, again, this is the notion of your requirements may change going forward. It's never quite possible to fully predict what's going to happen in the future, but you can always kind of prepare for what could happen, right? So like, let's say we had like a database system that managed like 100 users. Well, if we grow, our users might grow to 1,000 or maybe 10,000. We want to make sure that our system is ready for that, right? So we should future-proof it and not just make it work for 100 users. We should be cognizant, like, yeah, our user base might grow, our inputs might change. Let's prepare for that now, rather than race. Like when we, let's say we get a new contract and get 3,000 more clients. Well, then if our software kind of just like craps up, then we're not going to be a good, they're not going to come back to us. We're not going to have good credibility for our software. So always try to future-proof in terms of anticipating what could change going forward and kind of code for that now as best as possible. Again, never exact science to know what's going to happen, but you could always kind of smartly anticipate what might happen. And we talked about reliability and readability. Again, I'm not going to go too much into this, but readability, just following like coding standards, commenting your code, small stuff like that improves your code. Again, it's not going to improve your efficiency, but it's going to improve just your overall quality, especially when you're working on teams, like following the best practices and coding standards and naming conventions, stuff like that goes a long way in terms of having quality code. We talked about functionally on a high level. Again, just to review, like UI, UX design is very important when you talk about functionally how your code can be improved. Visual presentation, how intuitive is your application? Again, if you're developing a website, how easy is it for your user just to like hop on there and navigate, right? So like they should be able to understand how they could log in, how they could like interact with your data or whatever you're presenting to them. Again, it should be pretty obvious for a new user to kind of pick up your application and just use it right out of the box. Error checking, error handling, again, just you want to make sure that if errors do happen, that you catch them rather than like just crashing your application or just like causing your users to lose their data or something worse. So always good to kind of have that built into your code. And then features. I mean, this just makes general sense in terms of the more features you offer with your application, the better better coding solution it generally will be. All right, so that's functionally. And then we talked about algorithmically. Again, we've talked about this in our Big O lecture, our code complexity lecture. Usually comes down to two main optimizations. One being speed optimizations, how quickly can your algorithm achieve the correct solution? And then there's also resource optimization. So this usually is memory usage. How much memory is your algorithm using? Usually, for the most part, speed optimizations are the main focus for most software developers. Memory can be a factor depending on what, like how much memory you're using. If it's memory intensive, like I know like often video games can be very memory intensive because they're processing a lot of data. So you might need to like optimize how you use your memory. But for the most part, speed optimizations are the usual focus for improving your algorithms. All right, so we've talked about this before, but let's actually talk about how we can improve. So we're going to be talking about optimizations. Again, this is something we haven't focused too much on with our past lectures, but definitely want to have some focus on it. So optimizations. There's different flavors of optimizations that you can make and find within your code. So I'm just going to talk about these buckets. So one is called low-hanging fruit improvements. What I mean by low-hanging fruit are just things that are super easy to change in your code and will pay you some dividends in terms of greater speed. Again, anything I mentioned for speed can also go for memory. Like just if you improve your speed, you can also improve your memory if you make changes, but I'm gonna be focusing on speed. So low-hanging fruit is just like an obvious, like you just look at your code or you look at someone else's code and see some obvious change that just maybe takes like a few seconds maybe to implement, and you actually get some dividends out of it. So it may not improve your code a lot, but it's gonna be easy to implement and give you some improvement right away. Other ways, other things you'd be looking out for, look for redundant work that your algorithm is doing. So this is where, are we doing stuff that, we can cut out and still have the same exact, solution? So redundant work often creeps up where we're just like doing something in a lazy way, I guess, where we're just like, all right, we'll just do this, like this works. But we're actually doing extra work that we don't need to do. So we can cut out redundant work. Obviously, that's going to improve how efficient our solution is or how quickly our solution runs. Likewise, pretty similar, but different would be superfluous work. And this is just stuff that you just don't need flat out. Like, are you, let's go back to our palindrome example. Like, are you computing values outside of your range? Like for n equals 2, we shouldn't be multiplying 100 times 100 because those are 3-digit numbers. So that's just going to be extra work that doesn't even need to be done. So in that case, if we cut out like those extraneous multiplications, obviously that's going to improve our code efficiency because we're not doing extra work, so it's going to be quicker. Yeah, just try to identify stuff that you don't need. Again, this can happen from like legacy code, like as you modify a project that you have, like you might have code that does something with your initial solution, but then over time, whether it be like a team project that other people are adding to it, or maybe you just make changes. Sometimes a piece of code that was doing something at some point or had some meaning before no longer has meaning now. And it's easy for that code to kind of just get left in the code base, especially with large projects. But then if you actually take the time to analyze your code and realize, okay, this this for loop that we're doing is actually not doing anything for us right now, you can cut that out, and obviously that would improve your code. Common bottlenecks. So this is more just kind of understanding what is the slowest part of software applications, and it can vary depending on what you're developing. But the usual common bottlenecks are stuff that's happening outside your application, where you're communicating with something outside of your software. So typical examples for common bottlenecks are database calls. So database calls are relatively slow in the software, in your software, I guess, life. So computing values in Python or JavaScript, that's really quick. But calling out to a database and extracting information, that's pretty slow. So you want to minimize the number of times you're calling your database. You don't want to be constantly calling it just for single lookups. Usually you'd rather just get all your data at once and then store that internally in your application. So yeah, database calls can be slow. Any IO, so opening up a file, reading like a CSV file and reading that in, that's still relatively slow. It may seem quick, especially when we're not using a lot of data, but it is slow in a software development sense. So again, input, output, anything you're doing there is going to be slow. So you want to minimize that as much as possible. And then again, going for web development, we kind of talked about this. API calls, again, relatively fast, especially if it's a limited amount of data. Like it seems pretty much instantaneous, but they are still pretty slow. You're making a network request, so you got to travel all the way to the endpoint, and endpoint's got to respond. So there's some latency there. So that is a bottleneck often for web apps. If you're making a lot of API calls, especially if you have a lot of data, your user's going to notice that delay if you haven't coded it in a smart, efficient way. So yeah, just kind of understand. Again, this is more just with practice and kind of researching common bottlenecks. But again, usually anything that's external to your application, as in you're making a call outside of your software bubble, that's going to be a common bottleneck. So you want to try to mitigate that, or at least design around that so that your application isn't slowed down. So like in the web development we'd be doing, API calls are slow, but we're doing them asynchronously. So that doesn't have a huge impact on the end user in terms of the website's still, still interactive, or we can show other data while we're making API calls so that it seems quicker for the user, even though there's some delay getting the actual data from API calls. So there's also code profiling tools. This is a little more advanced, but these can help identify coding hotspots in your application. And these are great for large projects because, again, usually if you have 10,000 lines of code, you're not going to read all 10,000 lines of code each time you're trying to analyze it. Coding profile tools can basically run your application and then figure out where most of the time is being spent. And that can help you narrow down where to actually focus your attention. So if I run a coding hotspot or coding profiling tool and see that my function calculate palindrome is taking a lot of time, well, I'm going to know I should probably devote my time to fixing that because a lot of my algorithm's time is being spent there. And then once I improve that, I could run this again and see where my next hotspot is, or my next few hotspots are. So I could kind of look, okay, can I actually improve this, or is it going to be is it going to take 6 months to actually refactor this? Then I might pass on it. Then there's also micro optimizations. So these are, again, not going to give you huge gains, but within a large project, added up together, they can make an impact. So micro optimizations, again, that can be language specific, just certain approaches. Again, there's multiple ways to do the same thing often, but some methods might be faster than others. So we'll talk about this a little bit more going forward. Again, a lot of buckets here. Low-hanging fruit should be your first attack point because there's easiest to implement and give you gains right away. The bottlenecks and like finding redundant work, again, that's gonna be a little more effort because you gotta identify it and then figure out how you can actually adjust your code, whether you could just drop out code or modify your code so that you get rid of redundant work or extra work that doesn't need to be there. Any questions on optimizations? I know this is kind of theoretical, but kind of just understand there's different types of optimizations to locate and improve upon. Okay, so just be mindful of how you can kind of find optimization opportunities. But then there's also trade-offs that you should consider. So optimizations are great, but they sometimes come at a cost. So some examples I have here are minor optimizations versus code clarity. So let's say I have an application and I find an optimization that will improve my performance by 1%. But let's say that minor optimization that increased my performance by 1% resulted in my code being really hard to follow and maybe like 3 times as large. Or maybe that's, I guess, my next example. But let's say code clarity. Like I made this optimization, but it added so many lines of code that now it's not easy to understand what this function was doing. Well, then I might step back and say, well, is this actually worth it? Like if that's 1% is absolutely critical, then sure, I'm gonna make it, like if that's a requirement that we need the fastest algorithm possible, then sure, I'm gonna make that minor optimization and sacrifice some code clarity for it. But if this is a less like time sensitive algorithm, then I might actually opt for code clarity. Like why add complexity from a developer standpoint if that optimization isn't really that necessary, right? So again, if we're developing like something that's, you know, like maybe like a calculator that calculates values, well, you know, it's not gonna make a difference to the user if it takes, you know, 0.1 milliseconds or 0.99 milliseconds or 0.099 milliseconds, right? So at that point, code clarity would probably win out there just to make it easier to understand what the code's doing. Going to the next bullet point, we have unnecessary optimizations versus code bulk. So this is the idea of, you know, optimizations, again, that aren't really needed, and you're just bulking up your code. So like maybe something that's 5 lines of code might bulk up to 20 lines of code, might be, you know, a little more faster, but why am I adding so much code if I don't actually need it, right? So optimizations are great, but they aren't always needed. So definitely weigh like the, you know, trade-off there. Do you really want to bulk up your code base just to have some optimizations that no one really cares about? And then again, kind of balancing resources. Your developer time is a resource. Like for the company you're working at, your time is a resource that they have. So the question is, how much are you getting out of what you're spending your time on versus your actual time? Like where else could your time be used if you're not spending it on making optimizations, and kind of weigh which one makes more sense. So the example I have here is like, let's say we're making lemonade from fresh lemons, right? So we have a lemon wedge and we squeeze it once. Like we probably get maybe like 70% of the juice out of there. You know, is that good enough? I would say, no, it's kind of wasteful. We still have 30% and probably not too much more effort to get, you know, some extra juice out of there. So maybe I'll take that wedge again and squeeze it again. Maybe get like another 20% of what was remaining. So let's say we're up to 90% now. Okay, so, you know, we've put a little more effort with the second squeeze and got a little more juice out of that lemon. You know, we can squeeze it again, maybe like the next 5%, so we're up to 95%. But as you realize, like the closer and closer you get to the end, like you guys squeeze it harder and harder and you get less out of it, right? So eventually there is a cutoff point. So if we're making lemonade, right, I have a lemon wedge. How much time am I going to spend squeezing that lemon just to get the last few bits of juice or pulp out of it? At some point, I'm going to realize mentally like, hey, I have probably like, you know, 0.1% of juice left that I could get out of here, but I'm probably going to need like a professional grade press to get that juice out of here. Is that worth it? I think most of us would say no. Like, let's just get a new lemon wedge, or, you know, make a sandwich to go with our lemonade. But yeah, so again, optimizations are great to make, but understand that you are putting your time into it. And if you're spending, let's say you're spending 4 hours to improve your application by 1%, maybe not worth it, right? Again, if it's critical to have like the lowest latency possible, then sure, you're gonna have to make it. But if you realize, hey, it's fine if it doesn't work as fast as it could, then you kind of save your time and can work on something else, add a new feature to your website, or, you know, clean up your code, add comments. You could do so much more with your time than get that last, you know, 0.1% out from optimizations. So be mindful of making optimizations. Also be mindful of knowing when to stop. Know when it's not worth it to spend hours just to get a little more juice out of your code. All right, so definitely want to point that out when you're trying to improve your code. Know when to stop. All right, we're gonna get to you guys. All right, so we're actually gonna touch back upon the palindrome solution that we coded together. And I'm gonna ask you guys to make some optimizations to it. So I know some of you guys were already thinking like, oh, actually I can cut out a loop here or maybe do this in a different way. I'm actually gonna give you guys that chance. And let's see how you guys do with this. So I do have some code written for you, so you guys don't have to rewrite what we coded. So I'm going to give you a coded solution, a basic working coded solution. There's going to be some comments in there, so hopefully it's easy to follow. Keep in mind that this is a correct solution, so you don't have to validate, hey, is this producing correct results? But it's not, I'm telling you, it's not the most optimal solution. So there can be many improvements made to the solution I'm going to give you. Spend maybe, let's say, 20, 25 minutes once you obtain the solution and go through our checks that we talked about. Look for low-hanging fruit. Again, these are just the easiest optimizations you can spot and change so that you get some benefit out of it. Again, hopefully some of them should be easy to spot, but again, I've looked at this problem a lot longer than you guys, so I'm not going to say like, oh, it should be obvious in that sense. But if you kind of like, take some moments to look at the code, you should be able to spot some things that seem like they could be changed quickly and will improve your efficiency. Look for bottlenecks. So when I say bottlenecks, find out if you're looking at any algorithm, in this case, our palindrome solution, find out what's the most time expensive operations and see if we can kind of remove those or limit those, all right? So we talked about like, API calls. If we're making those a lot, if we can kind of figure out how to make them less or how to, make them more efficient, same idea here. So if you notice something that's relatively expensive within our algorithm, figure out if we can kind of avoid it or do less of it. Redundant work, unnecessary work, we've talked about this. Again, if you can spot stuff that we're doing either unnecessarily or we're just doing repeatedly, try cutting that out. That's going to improve your solution there. So I'm going to ask you to submit our solutions. We're probably running low on time, so we might take this up the solutions later, but definitely want to give you guys some chance to look at the code, and then we'll talk about optimizations once you guys get a chance to submit them. So let's go through that process. One thing I want to mention is timing your solution. So if you're interested in comparing, some adjustments that you make to the code, you can use something called console.time, and you give it your timer a name. So in this case, I named it timer_name, but you'd probably name it something more descriptive. You call console.time, then you make a call to your function. So in this case, we had largest palindrome as our function. So I'd add my call in between there. And then after that, I'd call console.timeEnd. And with that same timer name that I created that timer with, and this will actually print out the values of how long your function call actually took. So it's a pretty nifty, easy way to kind of get some relative idea of how your algorithm is performing by seeing the timestamps that are output by sandwiching it between these time calls. All right, so you kind of see if you're making improvements and seeing how much gains you get. Again, I'm not sure how precise this might be, but it's good enough to know if you're actually changing your code and improving it. All right, so console.time and console.timeEnd. All right, so here's my steps for obtaining the code. If you guys can go to this GitHub path, I'll actually post it in the Slack channel, so give me a second for that. Basically, there'll be a file in there called largestpalindrome_yourname.js. Rename this file, and instead of having your name, put in your actual name. I know we have a few Mikes and Kyles, so maybe use the last initial also, or maybe just use your last names, whatever you guys want to do, just make sure it's unique. There's a variable called name at the top of the file. Please set the value of that to your name if you can. So again, make that unique. So first name, or just last name, whatever. So replace that value. And then I have a function called getLargestPalindrome in there. Please do not change the signature, as in don't add any more inputs or take out any input parameters, nor change the name of that function. So please keep that function name the same. Again, that's not going to change how optimal the solution is based on the name of it. So yeah, keep the function signature the same. Spend the next, let's say 20, 25 minutes optimizing. So again, kind of scan the code, think about what's going on and see if we can figure out ways to either cut out code that code execution that doesn't need to be done, cut out loops that don't need to be done. Think about it that way. And then eventually submit a pull request. So fork from here, submit a pull request back to my source. Hopefully that should be possible. I haven't actually verified that, but yeah, just check it out, clone it, sorry, fork it, clone it, make optimizations, and then try to submit a pull request when I call for time. And then we'll actually go over optimizations together. Probably might be after lunch or maybe during stand down. But I would definitely want to give you enough time to go about it. All right, so we'll review after that. So let me post this in our chat, and then hopefully you guys should have access to it. Have that open somewhere. There it is. Please ask if you have any questions. I'm posting this in November chat, so you guys can clone from it. Fork and clone. I don't think you guys have write permissions, but you guys accidentally might. All right, so let's see. We have, what time is it? We have 10:24 here. We're gonna have our Beyond Tech presentation at 11. So let's say take the next 25 minutes to like 10:50 to spot any optimizations. And then we're gonna ask you to submit around 10:50, and then we'll take a 10-minute break before the Beyond Tech presentation. Any questions? If you guys run into any errors, again, I'm not sure if you guys will be able to submit a pull request. I haven't tested that out, but you should be able to fork and clone down this repository. So again, there's one file in here that has a solution. So if I open this up, again, I have comments. There's this name parameter, so please rename, add your name in there. And then I have my solution with comments, so it should be pretty easy to follow. Figure out any optimizations you make to this. Test it out with n equals 3. That's a good middle ground. You could try n equals 4. That takes a little more time algorithmically. N equals 5, n equals 6 can take a lot of time, so be prepared for that if you want to test those out. Just the runtime can be really long. Yeah, again, any questions, and feel free to ask. Otherwise, let's take the next 25 minutes and see what optimizations you guys can find.